Dear students, today we'll be talking about equations of motion. Equations of motion help us in relating the physical quantities that we have learned so far. So we'll be deriving the three equations of motion here. The first equation, V is u plus at. The second equation, S is ut plus half at square. And third is v square minus u square is 2as. Equations of motion relate final velocity, initial velocity, distance, and the time taken to cover the distance. Remember, equations of motion are valid for uniformly accelerated motion. That means the object must be experiencing the change in velocity at a uniform rate. Let us derive the first equation of motion graphically, which is V is u plus at. Let's consider the motion of an object where the object is already in motion with a velocity of say u meter per second, and it gains a velocity of v meter per second in some time t. This is t second. So graph for such a case can be plotted like this. This is a Vt graph for the motion of an object which is already moving with a velocity of u meter per second, gaining a velocity of v meter per second in time t. Now, apart from these terms, we have one new term, that is a. So, we'll have to use a concept of the Vt graph where acceleration can be found by finding the slope of Vt graph. If we look for the slope of this Vt graph, it can be written as change in y-axis upon change in x-axis, y upon x. Fine. What is AB? This AB length can be v minus u. This total length is v and this length is u. So the remaining is v minus u. So we can write it as v minus u, and this is parallel to time axis t second t, and slope of Vt graph always gives us the acceleration. So we can say a into t is v minus u, or v is u plus a t. So this is how, by using the concept that slope of the Vt graph gives us the acceleration, we can derive the first equation of motion relating these four physical quantities. The same graph can be used for deriving the second equation of motion, which says S is ut plus half at square. Now we have one additional term here, S, distance, and the concept that we know is that area under the Vt graph gives us the distance traveled by the body. So we can find the area under this line, which is the area of A, B, C, D and E. We can say these points are A, B, C, D, E. So we can say area under Vt graph, that is the distance, is equal to area of triangle ABE plus area of rectangle BCDE, or we can say this is area of triangle ABE, half of base BE into the height AB, right, plus area of rectangle BCDE, length into breadth. So it is BC into DC. So this can be half into BE is T, AB is V minus U, BC is U and BC is T. Right? So we can say, we can just jumble them. UT plus half into T into V minus U is AT from the first equation of motion. This is from the first equation of motion. This is known to us. So we can say S is UT plus half AT square. Fine. So this is the second equation of motion. So here we have related these physical quantities using the second equation of motion. Now let's go for the third one. Now the third equation of motion, which says v square minus u square is 2as. Now for deriving the third equation of motion, again we are talking about the distance, so somehow we need to talk about the area under the VT graph. But this time we'll be finding the area in a different manner. This time we can say the area under this line. So this area can be the area of trapezium OABC, right? So this is half of sum of parallel sides, the formula for the area of trapezium. Half of sum of parallel sides. The parallel sides in this trapezium are OA and BC. So OA plus BC into the height, perpendicular height, which is this one, OC. So we can say this is half of OA is U. This total length BC is V into OC is T. Right? Now when I look at this and this equation, third equation that I want to derive, I do not have any term called time factor. It is not there. So I need to eliminate this term T. So again, using the first equation, I can say T is V minus U divided by A. Right? I can replace this term as half of U plus V into V minus U divided by A, or this can be 1 by 2A into V square minus U square. Right? We can take this term 2A to this side now, and we ultimately reach at our result, that is V square minus U square is 2AS. Hence we derive the third equation. I hope the derivation is helpful to you. Thank you.